Hello students, today let us solve the problem related to kinetic theory of gases. The question is given, when the volume of the system is increased 2 times and temperature is decreased half of its initial temperature, then pressure becomes. 4 options are given, 2 times, 4 times, 1 by 4 times and 1 by 2 times. So this question appeared in AIEEE 2002. So to solve this question, let us take the ideal gas law, that is, PV is equal to nRT. So here what we have to calculate? We have to calculate the pressure. Okay. So the question is, the volume of the system is increased 2 times. Temperature is decreased half of its initial temperature. Suppose I will consider here we have to calculate the pressure. So I will rearrange the equation as P is equal to nRT by V, where P is the pressure, V is the volume of the system, N is the number of moles, R is universal gas constant and T is the temperature. Okay. So for initial pressure P1, nRT1 by V1. So then what happens? The temperature, the next temperature is a half of the initial temperature, or T2 is equal to T1 by 2. What happens to volume? Volume V2 is equal to 2V1 because it is increased 2 times. Okay. So now P2 is equal to nRT2 by V2. Now substitute P2 is equal to nR. T2 is T1 by 2 and V2 is 2V1. Again, I will rearrange the equation, that is nRT1 divided by this 2 goes to the numerator and it becomes 4V1. Okay. Again here nRT1. nRT is nothing but PV. Okay. So P2 is equal to, this is P1 V1 divided by 4V1. So now V1 get cancels, then P2 is equal to P1 by 4, or this is 1 by 4 times. So at this condition the pressure becomes 1 by 4 times, which is the third option, that is 1 by 4 times. So this is how to solve the problem using the ideal gas law. Thank you.